Hello students, so in this video we're going to learn how to find the gradient of a given line using this formula called rise over run. So what does rise represent? What does run represent? If you look at the screen, the rise is highlighted in red, which correspond to this red dotted lines that my cursor is moving at. The run is the horizontal distance highlighted in yellow, correspond to these dotted lines that my cursor is pointing at. Right, so to find the gradient of a line, you just basically need to find the value for the rise and the value for the run. So how do we go about finding the value for the rise, the vertical distance? So if you look at the diagram, basically you just need to draw a right angle triangle. That means you identify 2 points. Okay, you identify any 2 points on the line. Currently, the points that I'm using is x equals to -3, y equals to -1. This particular point that my cursor is pointing at, -3, -2. The other point that my cursor is pointing at, it's -1, 2. So therefore, the rise is actually the difference in the value of these two y coordinates, which is -2, the point that's higher, the y coordinate is 2, right? So it's 2 minus -2. 2 minus -2. So give you 4 units. Or from the diagram, you can see that, look at where my cursor is pointing. From this part here to the x-axis is 2 units, right? And then from the x-axis to below is another 2 units. So that gives you 4 units. Or just 2 minus -2, as demonstrated here. 2 minus -2 gives you 4. That is your rise. Your run is the horizontal distance. If you were to look at the diagram itself, then of course, this is 1 unit, 2 units. Okay. Or if you were to use the x coordinate, okay, you'll be shown here, -1 minus -3 gives you 2 units. So therefore, you'll be just 4 divided by 2 gives you 2. So the gradient of this line will be 2. Okay, let's give you another example. Supposing I choose another 2 points. Let's say let me type in the value. Let's say 5. Okay. And then 3. Oh, sorry. 5 and 2. Not much difference. I need to show you a greater difference. The horizontal distance will be 1 and 7. Okay. So now we can see it clearer. So let's look at your rise. So rise will be the one that's highlighted in red for you. Can you see? So how many units are there? 1, 2, 3, 4, 5, 6. Or you take the y coordinates of your point 2, 7, minus away the y coordinates of your point 1. So it's 7 minus 1 give you 6. Then let's look at the run. The run will be 1, 2, 3, 4, 5, 6, 6. All right, but why is it -6? Because remember in part A of the straight line equation, we agree that the line that's slanted in this direction will have negative gradient. So even though there are 6 units, you need to put a negative there. So it's 6 divided by -6 gives you -1. So here I've actually shown you 2 different ways of finding it. One way is just draw a right angle triangle, read out the values for the rise, read out the values for the run, and then use rise over run to get the gradient. But just be careful, okay, because if it's a line that's slanted this way that demonstrated on the screen, then the run will be a negative value. Otherwise, you can just use the formula here. You take the y coordinates value of the second point minus away the first point, and then the x coordinate values of the second point minus away the first point, and take 65 by negative 6. You will get the same answer. Okay, let me show you again another example. Supposing I want to use, okay, it's 2 point, okay? Right, so you can see that the rise is 1, 2, 3, 4, 5, 7 units. The rise is 1, 2, 3, 4, 5, 6 units, or 7 minus 1. 7 minus 1, 6. Then the run is 1 unit here, but it's negative 1 because, like what I mentioned, is this direction. The line is slanted this direction, so it's negative 1. Or just take 2 minus 3, x2 minus x1. Okay, because you start off with y2, so you have to use x2. Okay, you cannot mix. You cannot say I use y2 minus y1 and here I use y1 minus x2. No, you can't. If you use y2 minus y1, then for the run must be x2 minus x1. Okay? So that's how you find gradient. Okay, then what happens if it's I'm going to use a vertical line. Okay. So you see now that this is a vertical line. The equation is x equals to 3. This line has an equation x equals to 3. And you see the gradient is undefined because you are actually having run to be 0 and rise to be 6 units. See the one highlighted in red color, there's 6 units there, but 6 divided by 0 will give you mathematically undefined. Okay, so a vertical line will have undefined gradient. What happens if you have 0 for the rise? Okay, so if it's 0 for the rise, right now the run is 2 units. You will see that the rise is 0. 0 divided by anything will be 0. 0 divided by 1 will be 0. 0 divided by 2 will be 0, so on and so forth. So a horizontal line will have 0 as the gradient, and the vertical line will have undefined as the gradient. I'll see you in part C of the video.